Hello students. In this video, we're about to explore the fascinating world of number systems and polynomials. These concepts are like keys that unlock the mysteries of how numbers work, helping us solve all sorts of mathematical problems. Let's start with natural numbers. These are the numbers we begin counting with, 1, 2, 3, and so on. For example, counting apples, those numbers you're using are natural numbers. Next, we have whole numbers. They're just like natural numbers, but with a little addition, 0. So, 0, 1, 2, 3, and so on are all whole numbers. They help us count things without ever going into the negatives. But what if we include negative numbers? Then we get integers. Integers are a step up because they include positive numbers, negative numbers, and 0. Numbers like 3, 0, and 7 are all integers. But remember, they don't include fractions or decimals. Now, moving on to rational numbers. These are numbers that can be written as p by q form where p and q are integers, q is not equal to 0. Like 3 by 4 or 0.75. But some numbers are a little more mysterious, these are called irrational numbers. These numbers can't be written as fractions, and their decimal form goes on forever without repeating. Numbers like square root 3 or pi are perfect examples of irrational numbers. Together, real numbers include all the types we've just talked about, rational and irrational numbers. So, any number that isn't imaginary belongs in the real numbers category. Speaking of irrational numbers, let's discuss some interesting things about them. If you add or subtract a rational number and an irrational number, you'll always get an irrational number. If you multiply an irrational number by a non-zero rational number, the result is still irrational. But if you add or multiply two irrational numbers, the result could be either rational or irrational. Now, when we deal with numbers and their powers, we sometimes need to use exponents. For example, a raised to power m into a raised to power mn equals a, m plus n. Let's talk about terminating decimals. These are decimals that end after a finite number of digits following the decimal point, like 0.55 or 3 by 8. On the other hand, a recurring decimal is a decimal representation of a fraction where one or more digits repeat indefinitely after a certain point, like 5 by 6, which repeats forever. Now, let's come into the world of polynomials. A polynomial is a special mathematical expression made up of variables and coefficients. For example, x squared plus 2x plus 1 is a polynomial. Each part of the polynomial is called a term, and the number that multiplies the variable is called the coefficient. So, in the polynomial 12x squared plus 6x plus 4, the terms are 12x squared, 6x, and 4, and the coefficients are 12, 6, and 4. There are different types of polynomials, too. If it has just one term, we call it a monomial. If it has two terms, it's a binomial. And if it has three terms, it's called a trinomial. The degree of a polynomial is the highest power of the variable. For example, in 5x squared minus 2x plus 1, the degree is 2. The zeros of a polynomial are the values of the variable that make the polynomial equal to 0. For example, if p, x, equals x squared minus 5x plus 6, if x equals 2, we get 0, so x equals 2 is a 0 of the polynomial. Now, there's something called the factor theorem, which tells us how to find the factors of a polynomial. If you substitute a number into a polynomial, let's say p and get 0, then x minus p is a factor. The remainder theorem is helpful when dividing polynomials. It tells us that if we substitute a number into a polynomial, the result is the remainder of the polynomial. Let's wrap up with some important identities in math. A plus b whole square equals a squared plus 2ab plus b squared. A minus b whole square equals a squared minus 2ab plus b squared. A plus b, a minus b, equals a squared minus b squared. A plus b plus c whole square equals a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ca. A plus b whole cube equals a cubed plus 3a squared b plus 3ab squared plus b cubed. A minus b whole cube equals a cubed minus 3a squared b plus 3ab squared minus b cubed. A cubed plus b cubed equals a plus b, a squared minus ab plus b squared. A cubed minus b cubed equals a minus b, a squared plus ab plus b squared, a cubed plus b cubed plus c cubed minus 3abc equals a plus b plus c, a squared plus b squared plus c squared minus ab minus bc minus ca. If a plus b plus c equals 0, so, then a cubed plus b cubed plus c cubed equals 3abc. X plus a, x plus b, equals x squared plus a plus b, x plus ab. These identities are super helpful for simplifying math problems quickly. And that's our journey through the world of numbers and polynomials. So, here's a quick question for you. What's a polynomial with two terms called? Drop your answers in the comments, and let's keep learning together. The complete curriculum for Class 10 is available on our channel. Check out all the links provided in the description below. Please make sure to like, share, and comment for more such videos.